Now coming to the solution of the quiz of 8085 programs, I have given you 5 different programs in the form of Google Forms. So let's discuss one by one. Program number 1 was consider the following instructions, and based on these instructions you need to tell the output at port 1 will be what. So the first instruction, that is move immediate into A. That means immediate data that is provided in the operand here will be moved into the accumulator immediately. So when this gets executed, we'll get A equals to 8E. A becomes 80. Now when the next instruction ADI 73 gets executed, that ADI is add immediate data, and immediate data 73 is available. So we need to add 73 immediately with the accumulator. So accumulator will add the data 73 with the accumulator contents itself. So this A will now become 8E, that is previous accumulator data, plus 73, that is immediate data provided, and that will become 01 along with 1 carry. Now how? See with this. This is 8, this is E, this is 7, and this is 3. So when we add 0 with 1, we'll get 1. When we add 1 with 1, we'll get 0 carry 1. Again 1 plus 1, that is 0 carry 1. 1 plus 1, that is 0 carry 1. 1 plus 1, again 0 carry 1. 1 plus 1, 0 carry 1. This 1 plus 1, 0, again carry 1. And then 1 plus 1 is 0, and we get a carry 1. So the content in the accumulator will now become 0 and 1 along with 1 carry. So this carry flag will be set, and this 0 1 comes in the accumulator here as 0 1H. Now the next command says the jump on display, jump on carry. When the carry flag comes, if carry flag is set, then go to display. So here this command says that we need to go to the jump, we need to jump to the display. Now display is here, that means we are going to jump from display, from this line to this particular line. That means we have skipped these two. So these two lines, these two instructions will be skipped because we have jumped to display. Now when display XRAA comes, that means this XRAA does what? It clears the accumulator. That means A will become 0 0. A XOR with A is simply 0 0. And the next command is out to port 1. That means accumulator content will be displayed at an output port, which is port 1. So the content of accumulator, that is A equals to 0 0, will be displayed at port 1. And the next instruction HLT says that terminate the program or stop the program, stop the execution. So after the execution of this particular set of instruction, we get the A equals to 0 0 at port 1, which is the answer. Clear? Next question is consider the following loop. This is the loop, and we need to check how many times this loop will be executed. Now this XRAA does what? It clears the accumulator. In previous example we have already studied. That means it clears the A, and with clearing of A, that means A will be 0 0. That means the content of the accumulator will become 0. That means 0 flag will be set. LXI B0007, that means BC pair will be immediately loaded with the content 0007. So this LXI B0007H loads the BC pair with 0007 immediate data. Now comes to the loop. The first line of the loop says that decrement BC pair. That means BC pair will become 0007 minus 0001, that means 0006. And jump on non-zero loop. If z equals to non-zero, that means it should be fixed to the loop. But this DCX command does not affect the flag. This is the most important thing about this DCX command. So DCX does not affect the flags. So the only thing that changes the flag is obviously the first instruction, that is XRA. So in the beginning of the instruction XRA, this Z0 flag is set. So Z is equals to 1. There is no Z equal to 0. That means this does not come back to the loop. This will terminate here. So this command does not get executed, and don't go back to the loop because ZF equals to 1. Z is ZF, that is 0 flag. 0 flag is already 1. So it does not go back to the loop because it will go back when this jump on non-zero. So when the ZF equals to 0, then only it go back to this. Otherwise it will simply does not do anything. So after the execution, we find that the loop will execute only one time. Clear? Next is, if we have this particular loop and we need to check that how many times this loop will be executed. It is almost similar to the previous case, but we have not used XRA command here. Now this LXI B000A, that means this B C pair will be loaded with 000A immediate data. Now loop starts here. In the first line of the loop, we are decrementing the content of BC pair, DCXB, that means decrement the BC pair by 1. So BC will be 0001 and the loop starts running for the first time. Then move A comma B, that means the content of B will be loaded, will be moved to the A. B is 00 and C is 09. So B is moved to A, that is 00. ORAC does the ORing the accumulator with the C register. So C has 09 and A has 00. So this OR command will do the ORing in between 00 and 09. So this will become 09. And when it becomes 09, it simply becomes 09. And this OR command set the zero flag or changes the 0 flags or the other flags, and hence and we are not having 0 in the accumulator. That's why 0 flag is not set. Why we are only considering 0 flag? Because the condition next, that is jump on no 0, that means we need to check the 0 flag only. So when 0 flag is non-zero, again it go back to the loop. It rotates, it go back to the loop until it become 0. That means Z flag, 0 flag will become 1. So J and Z loop, that means it jumps to the loop again. So it jumps back to the loop. Next is, obviously this does not execute it because BC is already having 9 in the previous case. So decrement B, that means it will become 8 second time. Then move A comma B, A will become 00, or A with a C, that means A with 0, A ORed with 08, C, that means it will be 08, and again 0 flag is not set. Jump on non-zero, again this jumps to the loop again. So similarly, third time it will happen, this will become 7, this will be 0, this will be 0 and 7 to 7. Again 0 flag is reset, it again jumps back to the loop. Fourth time it will become 7 minus 1 6, A will be 0, A OR with C, that is 6, again ZF equals to 0, it again jumps back to loop. Fifth time it runs, when 6 minus 1 will become 5, A will be 0, A OR with C, that will become 5, again ZF equals to 0, again it jumps back to the loop. Sixth time it will be 4, A OR with C, again it's 4, ZF equals to 0, again it jumps back to the loop. 7th time it will become 3. A OR with 3, that means 3, again ZF equals to 0, again it jumps back to the loop. 8th time it will become 3 minus 1, that is 2. A equals to 0, 0 0 OR with 0 2 will become 0 2, and ZF equals to 0, again it jumps back to the loop. 9th time it will become 2 minus 1, that is 1. A is 0, 0 with 0 OR with 1, that means it's 1, again 0 flag is not set, it again jumps back to the loop. 10th time this 1 minus 1, that means it will become 0. A will be 0. C ORed with A, that means 0 OR with 0, that means now the content of the accumulator will become 0, and 0 flag is now set. So 0 flag is now set. When 0 flag is set, that means the next condition J and Z to loop, it does not go back to loop as ZF equals to 1. So the number of times the loop runs is the 10th time. So the total answer is the loop will run 10 times. Next question is, consider the following instruction, and we need to check what are the contents of the A after the execution of the program. The program is this. So let's discuss one by one. MVI A, that means immediately 07 is moved into the accumulator. So A will become 07, or 0000000111. RLC, that means rotate accumulator left without carry. That means A will become, every single content is rotated 1 bit to the left. So this 0 will become, gets outside, and this will be in the LSB side. This comes in the LSB side. So this will be 0 0 0 0 and 1 1 1. This will be empty. So this will be, this 0 of the MSB comes to the LSB. So the data after one RLC command will become 0E. Now this data is moved into B register. Move B comma A says this particular thing. That means B will become A, that is equals to 0E. Next is RLC. That means again we need to rotate left 1 bit. That means this 1 comes here and this 0 comes to the LSB. So this will become 0 0 0 1 and 1 1 0 0, that is 1C. Again in the next instruction it will be rotated 1 bit left. So this will become, this 1 comes here. So this will become 0 0 1 1 and 1 0 0 0, that is 38 in hexadecimal number. Now we need to add this accumulated data with the data available or present in the register B. So we are adding the data A with B. So this A will become 0E plus 38. 0E is B and 38 is A. So 0E and 38 will be added. So this is 0E, this is 38, and when we add we get the 0 0 0 1 0 1 1 0 1 1 1 0, carry 1, this 1 plus 1 0, carry 1, this 1 plus 1 0, carry 1, this 1 plus 0 plus 0, that is 1, and 0 plus 0, that is 0. So the answer will be 4 6 46. A will be 46. Clear? Next, fifth question has this particular thing, and we need to check for different types of data what will be the output. So data is this. So in place of this data we need to place 58 one time, another time it is 64, another time 73, another time B4, another time C8, another time FA. So I have classified this particular question into 6 different categories, assuming one data byte at a time. So here is the first data byte. 58 is considered to be a data. So when MVI A comma data executes, then it will put the data 58 into the accumulator. Now this MVI B comma 64, that means immediately 64 data gets into the B register, that is B will become 64. Now MVI C comma C8, that means C immediately moved into C8 is moved into C register. Now we compare with B. Now this compare B is compared with the data available in A. So A is 58 and B is 64. So these two datas are compared. This comparison is done like A minus B. It does not change the data in the accumulator. It only set or reset the flag. So A 58 is less than 64. That means we need to have yes, we need to set the carry flag 1 because the data is negative. So the data is negative, that means next instruction jump on carry, and jump on carry, that means jump to reject, RJCT instruction. So this line executes. Why? Because we already have carry flag set, so it jumps to reject. Now these four instructions will not execute it. Why? Because we have jumped to this particular line. So we have skipped these four instructions. So these four instructions will be skipped. And the next command reject, it is subtract A. That means A will become A minus A. So A is 58. And if we subtract 58 from 58, what we'll get is 0. And this 0 is displayed at the output port 1. So this display A equals to 0, 0 at port 1. And it HLT terminates or stops the program. So it basically stops. So the A will be 0, 0. That means port 1 has an output that is equals to 0, 0 when the data 58 is input. Next is when the data byte is 64. The same process is executed. Let's see one by one. When MVI A data executes, that means A will be 64. MVI B 64. Again B will be 64. MVI C C8, that means immediately C8 will be moved to C register. Now we compare B. Compare, that means A compared with B. So A minus B, that is 64 minus 64. 64 minus 64 equals to 0. So carry flag is reset. Jump on carry does not execute. Why? Because it is CF equals to 0. CF equals to 0, so it does not execute. So it skips to the next condition. Now we compare it with C. Now when A is compared with C, A is compared with C, then 64 is compared with C8. And here 64 is less than C8, that means carry flag is set. So carry flag is set, that means in the next instruction we have J and C, jump on no carry. So jump on no carry, that means again this condition does not fulfilled. So again it comes back to the next instruction. So this displayed the output to port 1. What output? The output which is available in the accumulator. So accumulator is having 64 data, that means 64 will be displayed at output or port 1. And this HLT terminates the program, stops the program. So this stops the program. That means these three lines does not executed. Clear? So the output at port 1 will be 64. Clear? Next, when we have data 73, that means 73 is immediately loaded into A, 64 in B, and C8 and C. Now we compare 73 and 64. That means carry flag is reset. Carry flag is reset, that means this command does not execute it. Now we compare it with C, that means carry flag is set. Again this jump on no carry does not execute. That means output A is displayed to port 1. 73 will be displayed at port 1 and program terminates. Program stops. So again in this data set these three lines does not execute. Clear? So the output display A at port 1, that means 73 will be displayed at port 1 in this particular case. Next is when we have B4 data, that means B4 is data. So MVI data, A will become B4, B will become 64, C will become C8. Now we compare A minus B, again CF is not set because data B4 is greater than 64, then this condition is not fulfilled. So we come back to the CMP C, compare C, that means A minus C is B4 is less than C8, so carry flag will be 1. Carry flag will be 1, so this jump on no carry does not execute. This condition does not fulfill, so it comes back to the next instruction, that is out to port 1. Output is displayed at port 1 output, that is display the contents of the accumulator, and again this HLT terminates the program. These three lines again does not execute, and the output A will be displayed at port 4, port 1, that is B4 will be displayed at port 1. Now the next data, that is C8. So when we execute this MVI A comma data, A is C8, B comma 64, B will become 64, MVI C comma C8, C will be C8. Now this compare B, that means CF is not set, jump on carry does not fulfill, that means it skips to the next instruction. Next instruction we compare it with C. Now when we compare A C8 with C, what we get is 0, because they both are same. When they both are same, carry flag is reset. When carry flag is reset, that means jump on no carry executes. So this line executes, and this says that jump to reject. So when jump to reject comes, jump to reject, that means these two lines does not execute. So these do not execute, or these are simply skipped. Now this reject says subtract A, that means A will become A minus A. A is C8, so C8 minus C8 will become 0. Output to port 1, that means A is port out to 0 at port 1, that means port 1 will have 0 0, the content present in the accumulator, and HLT terminates the program, so it stops the program. So after the execution, what we get that port 1 will have 0 0 output. Clear? Next is FA. When the data is FA, that means immediately data is moved in the accumulator, that means A will become FA, B 64 and C C8. Compare with B, that means CF is equals to 0. Previously we have seen in the previous examples, J C reject, it does not fulfill, so it comes to the next instruction. Next instruction CMPC executes. CMPC, that means CF is 0. CF is 0, that means jump to reject. Yes, it will jump to reject. That means these two instructions before the reject are not executed. That means these two instructions are skipped. These two instructions out port 1 and HLT are skipped. So these are skipped. Subtract A, that means A minus A. A will become FA minus FA, that is 0. Output to port 1, A, that is 0 0, displayed at output port 1, and this HLT terminates the program, so it simply stops the execution. So now what we get at output, A, that is 0 0, is displayed at port 1. Okay, thank you.